In the first two videos we looked at the age of our universe. But how do we know the age of the Earth and the ages of the rocks it contains? Fortunately, there are a number of different techniques, and they can all be checked against each other, and they all tell us the same story. Let's start with the benchmark, comparative dating. The golden rule is that newer sedimentary deposits are always laid on top of older ones. So except where rocks have been folded, this orange bed would be older than the green one, and the green one is older than the blue one. Geologists can then follow a single bed to make similar deductions in a different locality. The dark grey bed may be at the surface or even at a higher point than the others, but it's older than all of them, and the light grey bed is older still. What we end up with is what's called the geological column. To get the absolute dates of these rocks, scientists use a variety of different methods. I'll start with one of the easiest and most recent. We all know trees have rings because in summer they grow faster than in winter. But seasonal growing conditions vary according to the weather, so the bands will vary in size. Each time period in each geographical location has its own distinctive pattern of tree rings, like a fingerprint. So if we take wood of a known age, we can match the oldest part of it with the youngest part of another piece of wood, and so on back through time. Our upper atmosphere is constantly being bombarded by neutrons from the sun. When one of them hits a nitrogen atom in the air, it knocks off a proton, changing the atom from nitrogen into carbon. But this is a heavy and unstable form of carbon called carbon-14, or C14. The normal form of carbon is C12. In the atmosphere, C14 combines with oxygen to make carbon dioxide, which is then absorbed by plants and into the bodies of animals that eat the plants. The ratio of these two isotopes in animals and plants is roughly the same as the ratio in the atmosphere around them. But when the animal or plant dies, C14 decays over time and reverts back to nitrogen. So compared to C12, which doesn't change, the amount of C14 falls at a constant measurable rate. By measuring this ratio inside the dead animal or plant, scientists can find out when it died. Before I look at other dating techniques, I'll bat a few hoary old myths about carbon-14 out of the ballpark. No, it's not. That's like saying cars don't work because sometimes drivers get lost. Carbon dating works fine, but if the wrong stuff gets analyzed, then you'll end up getting the wrong date. So if there's bacteria or mold or any kind of contamination on the sample, the date will be wrong. If the results aren't calibrated properly, the results will be wrong. And in some environments, carbon dating is impractical, so the results will be wrong. But when everything's done properly, the results are right. That's no different to any sophisticated analysis technique, from X-ray imaging to spectroscopy. Contaminated samples don't invalidate the principle of DNA analysis or chromatography or spectroscopy. We know they work, and we know carbon dating works. Firstly, carbon dating can be checked against artifacts of known age, such as ship's timber. Secondly, it can be checked by sending the same artifact to different labs for analysis. Thirdly, let's take a sample of organic material from each of these layers. If carbon dating was random nonsense, you'd expect the chronological order of these samples to be all over the place, but that doesn't happen. The results show each of these samples in its correct chronological order. The ones from the upper beds are younger, and the ones from the lower beds are older. Is this magic, or is it because carbon dating works, and that's why it's used? Samples don't come with labels attached, telling the lab their age. Testing is always blind. If it's not blind, it's not science. But carbon dating isn't used on diamonds and coal, and for very good reason. As I explained, C14 is formed when neutrons collide with nitrogen atoms. The C14 used in carbon dating originated in the atmosphere. But you can also get it deep underground, in places where decaying uranium is giving off neutrons. Coal and diamonds are made of carbon, so you'd expect to find higher levels of C14 in coal and diamonds close to rocks that contain uranium, and much lower levels away from those rocks. And that's exactly what we do find. Carbon dating is only used and only useful for dating organic material in the topmost sedimentary layers. Now that we've got carbon dating out of the way, let's quickly run through a few more absolute dating methods. Biologists know that human DNA mutates at a fairly regular rate, and they can trace these mutations back, like following the branches of a tree back to the trunk. It's not a greatly accurate method, but it does give a rough idea of when humans migrated, and a very definite idea of where. Africa around 50,000 years ago, just as other dating methods suggested it should. Every 250,000 years or so, the Earth's magnetic fields flip over, and the South Pole becomes the North Pole. Magnetized minerals within rocks show the polarity of the Earth when the rocks were laid down, so throughout the geological column, rocks show a regular magnetic banding depending on the polarity of the Earth, and that can be dated. Potassium-argon dating works on the same principle as carbon dating, but instead of carbon decaying to nitrogen, we have potassium decaying to argon. And instead of a half-life of 5,500 years, we have a half-life of 1.3 billion years. That means the method can be used for dating rocks and fossils hundreds of millions of years old. The technique has largely been replaced with the far more accurate argon-argon method, and there are other decay processes that can be measured, each with different half-lives, such as uranium-thorium and rubidium-strontium. Radiometric dating takes us back to the oldest rocks we found on Earth, 3.8 billion years old. If you want to go back even further, you have to look into space. My video, The History of the Universe Made Easy, explains how we can calculate the age of stars and galaxies, so I won't repeat that here. Just take a look at the video. What's important is that the results fit perfectly with the chronology we find on Earth. The Sun, for example, doesn't turn out to be younger than the Earth or older than the universe. Its age, based on the amount of hydrogen fused into helium, is exactly what you'd expect. And as with dating methods devised for rocks on Earth, the method for measuring the age of stars and galaxies is devised first and tested afterwards. There's no way of knowing in advance what age these tests will show, but every time the age confirms the known chronology of our world. There's thermoluminescence that can measure the number of trapped electrons on the surface of volcanic rock. The speed that continents are drifting can be measured today, so their position millions of years ago can be calculated. It matches perfectly with the geological chronology we've already worked out. Climatic banding in sedimentary rocks can be measured, caused by a wobble in the Earth's motion every 12,000 years. I could go on, but there's no time here to list every dating method, let alone spell out the details of how they work. The important thing is that they do work, and attempts to show that they don't have all been spectacular failures. I've heard quite a few urban myths about these dating methods. Here are a few you may have heard. Yes, this really did happen. Because of the rate of radioactive decay, which is very slow, this method can't be used on rocks less than 100,000 years old. That's very young in geological terms, so most volcanic rocks can be dated using this method, and it works very well. But subjecting a sample of new rock to this dating method is rather like weighing an elephant on the kitchen scales. Any result you get is going to be garbage. Actually, the best way to date young volcanic rock samples is thermoluminescence. Obviously, if you want an inaccurate result, well then choose the wrong test, and that's just what you're going to get. This urban myth comes from a bogus test that was performed in 1990 on 4 fossilized dinosaur bones. The bones came from a museum and were heavily coated in preservative resin. Hugh Miller, who commissioned these tests, was told by the testing laboratory in Arizona that there was no carbon in the bones, so they couldn't be carbon dated. Now that's one of the most basic principles of carbon dating. You obviously have to have carbon in the samples, and dinosaur bones are so old the carbon has nearly always been replaced by minerals, as was the case with these samples. The laboratory warned Miller that carbon in the preservative resin would be measured, not the dinosaur fossil, which of course has no carbon in it. But Miller wanted to do the test anyway, I guess so he could pretend he had 20,000-year-old dinosaur bones, and he got the result he wanted. I suppose he could just as well have spread jam on the fossils and pretended that they were 5 years old. One of the golden rules about carbon dating is that you can't carbon date marine organisms, and there's a very good reason for that. The further away you get from atmospheric carbon, the less reliable the results. And the carbon that goes into marine organisms is very far removed from the atmosphere. So carbon dating is useless. In the 1960s, one of the biologists who discovered this phenomenon, known as the reservoir effect, warned other biologists about it in a scientific paper. To illustrate the point, he carbon dated live snails, and the result was 2,300 years. But while biologists have heeded the lesson and no longer carbon date marine organisms, the false dating has passed into urban mythology as proof that carbon dating doesn't work. So the simple answer to that is, on marine organisms, it doesn't. On land, it does. So not only do we have the intelligence to work out what happened in the past, we also have a number of tools to work out when it happened. And if anyone thinks these tools don't work, they shouldn't have to mislead or cheat. Just send samples of known age to a lab, ask the technicians to perform the appropriate test on the material, and see if they come up with the right answer. It's so easy to do. You have to wonder why the skeptics don't dare do it.